Hi everyone, welcome to my tutorial channel. So here in Open Academy for you, you'll find videos based on topics data science, machine learning and engineering topics. In this tutorial, now we try to see how to do exploratory data analysis using R in Google Colab. The reason for choosing Colab is we have all the predefined libraries and functions are all installed in that Colab. So everybody must have used Colab for Python applications, but in this particular tutorial, exploratory data analysis, we'll be using Colab to run our R applications. So first thing is we have to go to your Google Drive. So in order to create a notebook with our environment, so you go to this particular URL. In order to create a notebook with our environment in Colab, you select the particular folder of your interest. In this particular case, I'm using Colab notebook folder. So I have to type in this particular link. So Colab, and this is the link. So I'll try to create a Jupyter notebook based on our runtime environment. So if you try to run this particular link in the notebook folder, you will be creating a Jupyter notebook with our environment in Colab. So what we are going to do in this tutorial, we are going to perform a EDA analysis using R with a case study of a biomedical dataset. So the biomedical dataset what you have selected is a diabetes dataset, which is available in Kaggle. You can get more information about this particular dataset with this link. So if you try to go to this link, here you can see all the context of this particular dataset. So here you can see that it is a dataset based on diabetes detection, where they have selected a cohort of patients who are women, and they have collected different laboratory parameters such as BMI, insulin, glucose, age and other parameters. The outcome is you have to find out whether the patient is diabetic or not. So I'll leave it to you. You can browse through this Kaggle website and get more information about this dataset. Come back to a notebook. So we'll be doing EDA with this diabetes dataset. Okay. First thing is we have to set environment variables for the R. Very simple statement. So here I provide options for the R plotting. So here I try to fix size of the width as 8 cm and 4 cm for the height with a resolution of 200. This is generally for plotting the graphs in our environment. Okay, what is the library we are going to use for EDA? A very common and widely used library in R for EDA is nothing but tidyverse. All the important data manipulation libraries, functions are in this single library. It also has ggplot, where we can have very good visualization of your data. So run the cell. So it is running on the cloud, and we have loaded the options on the library tidyverse. What is the next thing we have to do? we have to import our data. So here I'm importing a data with a copy of this diabetes dataset from my webpage datalifex.in. So if you want to read a CSV from a URL, this is the syntax: read.csv followed by the URL keyword and the URL. So go on and run this cell. So now it has loaded the data frame data with the diabetes.csv file. Okay, first thing is we can check the different structures of the data. So for that we have to type in str and the data frame. So here you can see that what are the different predictors we are having for that dataset. You can see the pregnancies, glucose, BP, skin thickness, insulin, BMI, diabetes function, age. These are the predictors or features. The outcome is the target. So you can see that it is given as 1 and 0. 1 is for diabetic condition, 0 is for non-diabetic. Okay, so we can see the first few observations of this particular data frame by typing head data. So here you can see the various values listed in the data frame. So pregnancies to age and the target, which is the outcome given here. So once you see this output, you can very well see that we are having some issue with the data set. We are having a NA condition, so this is not available. We are having a missing value in this particular column of the data frame, glucose. Okay, so what we have to do is, in order to perform my EDA, the first thing is we have to clean the data. We have to remove the missing values and obtain a proper data set. So one way we can do is first check what are the different columns having missing values. Kindly understand that this particular subroutine is only for checking the NA. If your dataset contains other values such as NaN, not a number, or minus or plus infinity, or some other garbage value, it is our duty to check these values. But for this particular tutorial, we are taking a very simple scenario where we are having only the NAs. So this column sum is.NA will find out the NAs in each column and list out in a very easy to understand table. Just run this one. So now we can see that we are having pregnancies 0, glucose, we are having 2 NA values, which is obvious from this table, and likewise for other features. So the first step in EDA is you have to clean the data. So one method of replacing the missing values here is going for a median approximation, and that is very subjective. It depends on your application. But this application, we are going to use a median approximation for imputing the missing values. So what we do is we type in this particular statement. We are selecting the column which is having the missing value. So this is data, the data frame, and glucose is the column, and we are running is.NA, and basically we are asking a question: is the NA available in this particular feature glucose? If it is true, replace with the median value. So that is what it is given as a statement in R. So when you identify NA, you just replace with the median of that column. And let me try this one. So we have replaced the missing value with the median value and then checking the column sum. So here you can see that glucose, which had two missing value, it is replaced with the median values. We can verify that by running this head statement of the data frame, and here you can see that the two missing values we have approximated into its median values, which is 117 for that feature. The next one is, now we can perform a descriptive statistics. Before that, it is advisable to convert your target variable into a class variable. In R, we try to call it as a factor variable, because only with respect to the factor variable we try to perform the classification or other processing steps. So in this application diabetes, the outcome is our target. So I'm going to make the target as the factor variable. So this is the statement which converts the outcome, which was originally taken as integer. You can see here the outcome is by default it has been made as integer data type, but we are going to make it as a factor variable for our analysis. So what we do is we run this statement as dot factor, which will convert the outcome data type into a factor variable. Then we perform the descriptive analytics by going for summary. Let me run this cell. So here you can see that it has provided very good statistical parameters for all the predictors as well as the target variable, the minimum value, the first quantile, median, mean, the third quantile, and the maximum value. Likewise for each feature. And as we set the outcome as our factor variable, now it has listed out how many are in the class 0, how many are in the class 1, which is nothing but number of people without diabetes is 500, number of diabetic people is class 1, which is 268. So this provides a easy understanding of the distribution of our data. Next one is, in many applications we have to find out the distribution of data values. So in R we are having what is called the ggplot, which provides a way to find out the distribution of values by using Boxplot. So if you try to see the syntax, we are calling the ggplot function. You map your data, which is our data, and aesthetics you pass the x and y arguments. X is the outcome here, and I'm comparing the BMI for diabetic and non-diabetic. So y would be your BMI variable. I'm going to color it using the class variable. And as we are plotting a box plot, I'll be using geom_boxplot, and I'll be printing the plot. Let me run this one. So you can see that. So this is the box plot. So 0 means non-diabetic, 1 is diabetic. So we have plotted x is outcome and y is BMI, and the color we try to separate the two classes by passing the outcome to the variable fill. So what is happening here is we are having two labels, so it is filled with the two classes here, class 0 pink, class 1 as blue. So very easily you can identify the various properties of this data frame. You can see that the BMI of non-diabetic is less than the distribution of BMI values of diabetic patients, which is obvious. those who tend to be obese are more prone to get diabetic condition. So very well, we can try this for another predictor variable. So I'm trying here for glucose. So let me run this one. So this is the distribution of glucose variable for the two class variables, non-diabetic and diabetic. And here also we can infer that the glucose of diabetic condition patients are having higher values than people who are non-diabetic, which is also obvious. Next one is very common data visualization is going for Scatterplot. So for getting a Scatterplot, so we'll be using a function geom_point. So I'm doing a Scatterplot of relation between age and glucose. So you can see this syntax. So X we are mapping to age and Y to glucose, and we are coloring with the outcome. So when you run this one, so this plot shows the scatter plot of the relation between two variables, age and glucose, for the diabetic and non-diabetic subjects. And from the scatter plot we can see the line fitting here. So likewise for both the classes, and this gray areas are the standard error. And if you try to fit the line based on the distribution of data, you can see that there is a significant difference between the diabetic and non-diabetic subjects. This blue line, which is related to the diabetic condition subjects, you can see that the glucose level is high compared to the non-diabetic subjects. So you can see clearly how the data is being distributed relating to the age and the glucose. So likewise I can try for the relation between age and BMI. I run this cell. So you can see that very similar to the relation of age and glucose. Here we are having age and BMI, and it is also having a similar picture. The diabetic subjects, they try to have a higher BMI. You can see this blue line, which is higher than this normal subjects. So this is the regression of this distribution of data points, and the gray area shows the standard error. Next, I will end up this tutorial with a very important subroutine in R, which is hypothesis testing. So hypothesis testing is commonly used between different sample groups. So here we try to find out how BMI is having a relation to the occurrence of diabetic and non-diabetic conditions. First thing is we have to separate the BMI for each group by having two data frames, DF1 for non-diabetic, their BMI, DF2 for diabetic corresponding to BMI. So you try to retrieve the values for the two classes, store it in two different data frames. So this becomes one sample, this becomes the another sample, and you can very well perform the boost sample t-test to find out any significance differences present between the subject groups based on BMI. So go ahead and run this. So in R, we call t-test by this statement, t.test. This is your first sample. This is your second sample. So two sample t-test with a mean of 25 for the population mean. So when you run, you'll be getting a two sample t-test result, and you can see that the p-value is less than 0.05, which shows that there is a significant difference in the values of the two groups, namely the non-diabetic and the diabetic group, and they have a significant difference compared to a normal mean of BMI of 25. So this shows that the BMI can be a good indicator of the diabetic condition. So the BMI is significantly different between the two groups, namely the diabetic and the non-diabetic groups. So with this, I'll wind up the EDA analysis in R with our sample data set. I hope you can understand the basics of EDA in R by going through this tutorial. And if you like the video, kindly like it and subscribe for more tutorial videos like this. Thank you.